Dear students, today we are discussing theorem 7.10.2. Okay, so we have the situation of interchange of integration and differentiation. We can apply that theorem to develop new theorems. So this is the theorem under consideration. So let f and d be the function defined on the domain D, and lambda x2 and theta x2 be functions defined and having continuous derivatives. So in this case the range is a continuous function of x2, okay, and having continuous derivative on a2 comma b2 such that a1 less than or equal to lambda x2 less than or equal to theta x2 less than or equal to b1, okay, and for all x2 in a2 comma b2. Then the function g from a2 to b2 to r defined by g of x2 is equal to integral lambda x2 to theta x2 f of x1 comma x2 dx1 is differentiable for a2 less than x2 less than b2, and the derivative is dg by dx2 is equal to integral lambda x2 to theta x2 dou f of x1 comma x2 by dou x2 dx1 plus theta dash x2 into f of theta x2 comma x2 minus lambda dash x2 into f of lambda x2 comma x2. So this is a very wonderful result, and we need this result for deriving some theorems in real analysis as well in statistics. So we are trying to prove this theorem. Okay, so what is the given conditions? The range is a function of x2. Range is not a constant. Usually we are getting the range as a to b or 1 to 2 like this. So but here the range is a function of x2. So range is a function. Okay, range is a function of x2. So we have to differentiate with respect to x2. So we have to differentiate the function with respect to x2. At the same time, range is a function of x2. So it's very complicated situation. So we can simplify that differentiation using this theorem. So let us consider these equations. What is g of x2 is equal to, that is the integral lambda x2 to g theta x2 f of x1 comma x2 dx1. Okay, so let it be denoted as h of lambda comma theta x2. It is given here. Okay, so and you know that we can apply total. This can be considered as a single function. Okay, this can be considered as a single function of x2. Okay, so moreover the theta and lambda are the function of x2. So we have to adopt the total derivative formula for the differentiation. So what is the total derivative formula? Yeah, that is very simple. You know, dh by dx2 is equal to dou h by dou lambda into dou lambda by dou x2 plus dou h by dou theta into d theta by dx2 plus dou h by dou x into dx2 by dx2. So that is simply written as dou h by dou lambda d lambda by dx2 plus dou h by dou theta d theta by dx2 plus dou h by dou x only. So this is the total derivative formula we applied for the function h of lambda comma theta comma x2. Note that h of lambda comma theta comma x is nothing but g of x2. So we are using that notation h of lambda comma theta comma x2 because that depends upon lambda, theta and x2 as well. Okay, so this is the equation we have used. Now we consider we know that what is dou h by dou theta. Dou h by dou theta is, we can apply some mean value theorem. Okay, so what is the mean value theorem? You know that f dash of t equal to small f of t. I think we have used in this theorem. Yeah, this is this one 6.4.8. f dash of t equal to h of t. So instead of, we can write, so this is the case d by dt. Okay, so what do we write? Dou h by dou theta is equal to dou by dou theta of that function. Okay, h function, and this is nothing but some dou by dou theta of, or h dash of theta. It can be viewed as h dash of theta, capital H dash of theta, but capital H dash of theta is nothing but this is, yeah, this is f of theta comma x2. Okay, so using this expression, there is an, yeah, this is h dash of t equal to f dash of t. If we have this type of expression, we can write like this. There is some fundamental theorem. Okay, it's taken from fundamental theorem. So the dou h by, so similarly dou h by dou lambda, what will be dou h by dou lambda? Yeah, it is dou by dou lambda of lambda to theta. What is that? What is that? F of x2 comma x1 comma x2 dx1. But you can consider this as minus integral theta to lambda. Instead of lambda to theta, we can rewrite as minus integral theta to lambda. Interchange of order of what is that, range. If we interchange the range, there will be a minus sign. Okay, so that is a simple, you know, that result is very trivial, and we can apply the theorem. Okay, 6.4.8 again for this function, that will be result in minus f of lambda comma x2. Okay, so now the remaining part, the third part, for the third part of this equation 7.773, we can find out dou h by dou x2. What is that? Dou h by dou x2 is equal to dou by dou x2 of this function, and we can apply interchange of integration and differentiation, because we have assumed that f is partially differentiable with respect to in this theorem, and we are continuing this assumption of this theorem for the present theorem. So what is the assumption of this theorem? F from D to R, D subs to R2 contains two-dimensional cell, and suppose f is continuous and has first order partial derivatives, so then this interchange of integration and differentiation is possible. So we are adopting this information for the present theorem. Here we have said that let f and d be the same as in the theorem 7.10.1. So that assumption will be clubbed with this theorem. Okay, so you know, you can adopt that theorem, and instead of dou by dou x of theta, lambda to theta f of x1 comma x2 dx1, we can write integral of derivative. So by using the above theorem. Okay, so that is that we can so we can substitute this. We have three results. One is this one, first one, this is second one, this is third one, and we can substitute in the equation 7.73. So what will be the result? Yeah, making proper substitution in the formula 7.73, we can conclude that, what is that, d by dx2 of, let us substitute that result. Okay, what happens? That is a dh by dx2. Okay, what is h? H is nothing but integral lambda x2 to theta x2 f of x1 comma x2 dx1. So we have substituted that result. Okay, that equal to, what is 7.7.3? Dou h by dou lambda by dou x2. You know, dou h by dou theta is given here, that is f of theta comma x2. You can substitute that result. What is that? Yeah, f of this one is the, they have interchanged the what is that, position of the term. So first term will be this one will be the first term. So f of theta comma x2 into dou, what is that? Yeah, this second one. So for the first one will be the last term. Okay, they have interchanged that. So what is that? F of lambda x2 into dou lambda by dou x2, that is nothing but lambda dash of t. Okay, minus f of lambda x2 is nothing but dou h by dou lambda, and this is dou lambda by d lambda by dx2. So we have substituted. So instead of first term, we replace with first term, replace with this term. The second term will be this one, f of what is dou h by dou theta, that is f of theta comma x2. What is d theta by dx2, that is theta dash t. Now third term is actually, what is that? What we have obtained? Yeah, this one. Dou h by dou x2, that is nothing but lambda to theta dou f of x1 comma x2 by dou x2 dx1. So that is substituted there. So the result is obtained. So it is very easy to prove the this formula. This is, yeah, this one. Very simple and easy to understand, and you try to read and understand the concepts in this theorem. So it's very simple theorem. Okay, I think you got the idea how the proof is obtained. Now we move to some numerical examples. What is example? Yeah, we have to interchange. You have to find out d by dx2 of integral x2 square to cos x2 x1 x2 square minus 1. This type of formulas we have to understand in detail, because in our research or in our higher studies we may have to face this type of problems, or in sometimes we can see these types of problems in some competitive examinations. So we have to find out we have to understand the techniques involved in solving this type of problems. Okay, so that is required. You have some knowledge in what is a differentiation and integration. That is the knowledge up to the +2 standard. You know the differentiation technique and integration technique you are studying, or you know the integration techniques and differentiation technique up to the +2 level. I think so. You know the techniques up to +2 level. You don't know actually the integration differentiation results up to the degree level and up to the PG level. So you have to study that higher level integration and differentiation techniques, and sometimes we are always using the integration and differentiation technique up to +2 level. That is sufficient. At the same time, we have to, for the research or for higher studies, we have to understand this type of techniques. Okay, so what is d by dx of integral x2 square to cos x2 x1 x2 square minus 1 into e raised to minus x1 dx1? That can be solved as, yeah, it's very simple. Yeah, we can identify the f of x1 comma x2. What is f of x1 comma x2? Yeah, this is x1 comma x2 up to more times. Okay, so the integrand inside this integration result, that is the f of x1 comma x2. Identify that. So what is dou f x1 comma x2 x2? Yeah, differentiate with respect to x2 only. That what will be the result? x1 into 2x2 and the constant part e raised to minus x1. So yeah, that is appeared here. Now what is theta x2, theta dash x2? Since it is cos x2, it will be minus sin x2. It's very simple. What is f of theta x2 comma x2? So instead of x1 we can put cos x2. Instead of x1 we can put cos x2, that is appeared here. Okay, into e raised to minus cos x2. Instead of my x1 we use cos x2, that is appeared here. And the last term is minus lambda dash theta x2. We can identify what is lambda of x2. This is x2 square. So what will be the derivative? 2x2. Okay, it's very simple. And what is f of lambda x2 comma x2? So instead of x1 we will replace with x2 square. So the result will be x2 square into x2 square, that is x2 raised to 4 minus 1 into e raised to minus x2 square. Yeah, that result is given here. So it's very simple. So this type of examples you have to do and understand. Okay, so some other problems are given. Okay, you can try this problem. So okay, that can be submit when you write and submit in Moodle up to this, and along with this theorem and example you can submit this problem also. Okay, so that is left as an exercise. Now okay, we will move to the application of statistics in the next class. No problem. You study the result of that we have discussed till now. Okay.